Thanks everybody for taking time on this Friday afternoon to join the webinar. My name is Justin Patten. I'm a technical lead in the Creative and Digital Solutions group here at Netrix. What we're going to be going through today is how you can develop new capabilities for your district faster with cloud application development. So some of the items we're going to cover in our session today is why we should use the cloud to build apps. Then kind of what's an easy way to start doing that with virtual machines and some lift and shift scenarios. Once we get through the entry level scenarios, we'll also dig a little bit into microservices and how those tie into Azure Service Fabric and kind of the architecture of the future with those. We'll also touch on data services in Azure, so SQL Azure, Azure Table Storage, and Cosmos DB, and go through those and some pros and cons to each of those. And then finally, we will wrap up talking about DevOps and how we can leverage Microsoft and other tooling to streamline your deployment and integration of your different applications. So why should we use the cloud to build applications? First, we kind of want to do a little run through of Cloud 101, if you will, as far as why are we looking at moving our applications to the cloud versus running them on-premise. So there are several reasons to go that route. Number one being on and off, inactivity periods. This comes up a lot for development and test workloads. You have developers who maybe work 8 to 5 Monday through Friday. So why should we be running servers in our racks all the time when they only need them certain times of the day or certain times of the week? Growing fast used to be a problem to get new servers spun up and put in a rack so that people could even use them. So by moving to the cloud, we have at the click of a button, we can easily scale and get more resources available to us. Unpredictable bursting, using things in Azure such as performance counters or queue lengths. We can set up rules to make our infrastructure respond to how busy our site is. And then predictable bursting, think of somebody that's do payroll processing, so they know it's every 2 weeks. So they could set up rules within the cloud, within different automation tools to scale up and scale down the resources to accommodate that instead of paying 3 times as much as they need to just for that one day every 2 weeks. So scale is a big reason that we move workloads up into the cloud. So as I mentioned before, dev test is something that really lends itself well to running workloads in the cloud. We have several clients that choose to still run their production environments on-prem, but they definitely take advantage of the cloud for dev test workloads because of some of the things I just mentioned. Being able to turn things on and off, or maybe somebody needs to reproduce and test a bug and they need a whole new environment and then they want to turn it off. Giving developers and employees self-service to do those sorts of things can save a lot of cost in the long run. One thing that Microsoft also offers around the development and test space is something called a dev test subscription. So if today you are paying for Visual Studio subscription benefits, so you have Visual Studio or the old MSDN type licensing, you can actually get discounts on running those environments. You don't have to pay for the Windows licenses or the SQL licenses and those types of subscriptions. So the different vendors are trying to make it more appealing to bring even just the dev test workloads up into the cloud. So not just only on a scheduling from a week-to-week basis. Obviously, within the cloud, we can also schedule stuff on a month-to-month basis. The overall theme is that we can handle anything in the cloud that could be thrown at it. And not just from a cost perspective, but from a performance perspective, storage perspective, all those things we can scale up and scale down whether you plan for it or you don't. So let's take just a quick look at kind of how we got here from a cloud and IT strategy standpoint. So several years ago, obviously everything was running inside your own data center. Everything was running on physical servers, kind of one to its own server. Virtualization started to take off with VMware and Hyper-V and various other players. But even at that point, we still had some server sprawl, where people would request all these virtual machines, we'd stand them up, and people would never use them, and now we have all this hardware that's just sitting in our data center, essentially doing nothing. So at that point, people started looking at public cloud platforms, Azure, Amazon, Google, etc., and started moving some things up there. People wanted to get away from patching, so they moved to more the platform as a service offerings, which as a developer, that is one of the things that appealed to me the most about moving to the cloud. It removes a lot of the management around patching and antivirus and securing the server. Those things are all just taken care of for you now. So people started moving from infrastructure as a service over to platform as a service, which we'll talk about leveraging those in greater detail in a couple slides here. But even with platform as a service, those you were still responsible for, had to upgrade, had to push new deployments to. So then people started moving on to software as a service. But when I say moving on to, it wasn't like they gave up all of the other ones. So now at this point, you have your physical server still, you have some virtual servers running on premise, you have infrastructure in the cloud, platform as a service in the cloud, and software as a service in the cloud. So it just became a lot of things we had to manage, and this is still ongoing. So what we're trying to do with App Dev now is get you primarily into that platform as a service space. And just an overall holistic view of Azure and what it's capable of. Several items on the screen here. One of the big things to note is that it isn't just Microsoft products that we can run out in Azure, things we can do out there. Microsoft, especially from a development standpoint, is very heavily involved in the open source community and has very good support for Node.js, PHP, Java. All those things can easily be deployed through Azure. So let's say you have an application that you're currently running on-prem. You want to know how we can get those applications up and running in Azure quickly and efficiently. So those scenarios often are described as lift and shift, and it's kind of one of the first steps to take to do app dev inside of Azure. So today, maybe you have a virtual machine running on-premise, and you have an on-premise SQL Server that is hosting the database for that. What that looks like in Azure is, very closely resembles what it is today. You have a SQL Server virtual machine running in Azure, you have a virtual machine that's running the application in Azure, and then you have various means of storage inside of Azure. Since you're running virtual machines, you could just be using the hard drives that are attached locally to those machines, or you could also take advantage of some of the platform stuff if you wanted to update your code a little bit. The scenario that's being talked about here is exactly what it says. It's just a lift and shift. We're not changing any code to make it run in Azure or anything like that. We're purely just moving the code and the databases and where they live. So a really easy entry point just to get the workloads up there and prove that it works. But at this point, we aren't really taking advantage of any of the platform enhancements yet. Step 2 in here is kind of moving up into that platform as a service level. So we're taking from IIS and SQL Server on-prem, and we're moving into Azure App Services, used to be called Azure Websites or Azure Web Apps, and then we're using SQL Azure. So now in that workflow, we are no longer doing patching of the machine that's hosting SQL Server or the application server. We're not worrying about backups of my SQL database because Azure handles that for you in the realm of 30 days, if not more, depending on your tier, where you can restore to the nearest 5 minutes. So something you don't have to think about. You're no longer worrying about disk space on that SQL server because we know how much we can use within SQL Azure. And like I just mentioned, this same flow also applies for any of the other open source languages, if you will, around PHP, Node.js, and then MySQL actually does have a, it's in preview, but there is a Azure Microsoft hosted instance of MySQL. If you don't prefer to use stuff that's in preview, a vendor called ClearDB also offers hosted MySQL solutions. So again, trying to get you, spending time on the things that you as a developer, as the development team want to use code and deploy it to a server. You don't want to have to manage the underlying operating system, the underlying database server. We can get rid of all those issues by moving to a platform as a service type play. Other things you get with this, the ability to auto scale is built right into the different application service plans. There's built-in firewalls, DDoS protection, all these things that you may have to worry about in a virtual machine environment now are covered as a part of this. From a developer standpoint, you're really not changing any of your tooling. That's why it's another great entry point. If you want to publish from Visual Studio out to Azure, it's the same way you would publish to a server on-prem. If you're using VSTS or Jenkins or any of those automated deployment tools, it can deploy to Azure just the same as it did on-premise. The same thing is true with the SQL and MySQL hosted versions. All the tooling that you use today, you can just connect to those and everything's fine. Often the case in this scenario, it is just a deploy my existing code base out to Azure. Very little, if any, tweaks that you would need to do. But we are leveraging the platform and taking some of the maintenance and management away and not having to worry about those anymore. As far as deployment and staging, test, dev environments, those things within Azure, there are multiple ways to do it, and we will talk about the DevOps side in greater detail towards the end of the session. But I just wanted to highlight the ability to use slots within application services. So you can have multiple slots within an individual application service, and you can deploy to each of those slots independently. And what this allows you to do is run various tests, whether they be just functionality tests or load tests, any of those sorts of things, against different code bases without impacting the production environment. And by having these in there as slots, you essentially end up with zero downtime. Behind the scenes, it's doing a little bit of magic with DNS entries to say, make staging production now. But it is one way that you can easily stand up and test out new deployments before actually turning them on in production. The URLs are publicly accessible, so as long as you know what they are, you can get to them and test things out before you actually move it to production. Now, the alternative is to run multiple application services, which we'll show a little bit later. But using the slots is great for maybe once you've tested something fully, you want to deploy it to production, but you don't want any downtime in production while you're doing it. So you will deploy to the staging slot, go out there, log in, make sure everything looks good, and then you can just switch the slots over. So those are the easy high-level lift and shift scenarios that we have. The next section and things I want to talk about center around microservices and how Azure Service Fabric is built on top of those and how you can leverage those with your new applications or existing. So there's still the ongoing discussion in the industry about microservices versus monolith. And in my experience, it isn't an either or. Often an application will start out as a monolith and then evolve into a microservice. I've been to various events where it's been said that's actually the preferred method, that if you start out writing pure microservices, it won't be as efficient and may actually fail, versus if you would have just started as a monolith and then kind of backed your way into a microservice. So what is the purpose of going this way? By breaking things into individual pieces, they can evolve independent of each other. So if we want to change something in service B, we don't have to also test everything from service A because they are separate segments of code and have no overlap. There's a shared contract with how they can talk to each other, but that's about it. And since we can develop these microservices independently of each other, we deliver them faster, we can make changes to them faster, and those changes are isolated. And then we can also build them at scale. And we'll see that in a couple slides here about how now, since the individual pieces are split up, we can use our resources better and more efficiently. At the end of the day, cloud, we have all this scale capacity. More often than not, people aren't using even what they provision. I think the average number I heard from Microsoft is around 8% of CPU usage. is actually out there. So people could actually scale back a lot of the machines that they're running. Or we could get more efficient with how we're deploying things and then use more of that CPU. So what do monoliths and microservices look like stood next to each other? So in a monolithic application, we have 3 services that are a part of this application. When you scale up to another server, it puts a copy of those 3 services on every server you have. So maybe the yellow service on our slide here is the one that uses all the resources, a lot of CPU, a lot of memory. Now when we need to scale up for that, we are also getting multiple copies of the other services that are running. Maybe not a problem, but again, if the yellow service is using a lot of resources, it may be slowing down the other applications that are running there. So we could probably, deploy these and split them up a little bit better. So in a microservices approach, everything's split apart, and the individual services can be scaled independently. They can also have different redundancy levels. So maybe for the red service, I always want to have at least 5 running, and then the orange one, I want to have, maybe I only need 1 running. So we can control all of that through microservices, and then, like I said, scale them up independently. If we need another red service, we just stand up another red service on one of the other remaining servers that are there. So it just lets us use the resources we have in a much more efficient manner. One thing you do need to consider between the 2 different approaches, a monolithic application often just has a single source of truth, if you will, a big single repository, whether it be a SQL database, MySQL database, and everything ends up going down and getting its information out of there. When you move over to the microservices world, that data essentially has to be split apart. If we have service A that can actually reach into the data that service B controls, then we really can't deploy those 2 services independently of each other. So you have to manage state amongst different services, and then maybe you do have a single data repository where everything ends up getting rolled up to, but the individual services don't know how to do that or don't really control the data from each one. What is nice about this is that it allows you to use different types of storage depending on what the service needs. So if we have a service maybe that tracks just events that happen throughout our application, we could use something simple like Azure Table Store, which is a simple key value store, to track all those, because we're not having to run queries against it. We just want cheap, efficient storage that we can write to. So that's great for those. But then other cases, maybe we have data that's relational. Well, then in that case, we could use a traditional SQL Server or a document database if we wanted to. But the individual services determine where they store their data and how they access it. And then you have tools that also understand how to read all those. So you have things like Power BI that can talk to a Azure Table Storage or a SQL Server, so you don't necessarily have to roll all that up. But when going down the microservice path, it is important to remember that there is that split. It's not just an application code service split. The storage also has to be kind of independent so that you can upgrade and modify those independently of each other. So how does Service Fabric sit in here? Because microservices is definitely a general term. May have heard about Docker and Kubernetes and some of these other open source offerings around that. So Service Fabric is Microsoft's container offering that offers some great built-in features over and above just plain microservices. So we'll touch on some of the ones that are mentioned in here. One of the great pieces I like about Service Fabric is that it not only runs in Azure, kind of as a platform offering, but you can also run Service Fabric on-premise if you want to. You can also run it in other clouds, so Amazon, Google, Rackspace, any of those. Microsoft offers it as a free download that you can install on any Windows server and run it on there. And it also runs locally on your workspace. So if you have developers who are writing applications in Service Fabric, they will have a single node Service Fabric cluster that runs locally on their environment so they can test everything out. So some of the great pieces with Service Fabric, to me, around the health monitoring, rolling upgrades, automated rollback. So if you publish new software out to the Service Fabric cluster, and it runs into a problem during startup or starts running into errors as it's publishing, it'll actually roll that application back and leave the previous version in place. Microsoft now has something in place that the underlying cluster nodes are automatically patched, so you don't have to worry about that anymore. The programming of it, you don't have to learn a different programming language or how to talk, between services. They're real easy to use SDK that allows you to talk in between the various microservices you may have, whether that is a stateful service, which is actually something really cool where it's actually storing the data on the nodes of the cluster and trying to make things faster for response to the end users. Maybe it's something that you just want to keep in memory. Think of like a shopping cart. Maybe you don't want to write that down to a database somewhere. You could store it on the hard drives of the different cluster nodes and retrieve it right from there. They do have the option of stateless services, and then they support actors as well. So you can do a lot of different things around the microservice platform. Kubernetes, Docker, those other sorts of containers are definitely supported in Azure. The kind of guide we usually give is if you're in the .NET space, you're probably better off going with Service Fabric. There's better support for it, and it's fairly easy to use. But anything in the open source side of things, you may be better running inside like an Azure container instance or something like that. You can run essentially any executable inside of Service Fabric, but you may not get all of the bells and whistles that come along with writing a native Service Fabric application. So how does that all look? If you're familiar with the traditional Azure cloud services that they used to have, which were web and worker roles, you essentially could have one role that would run on an individual VM. It had the auto-scale support and things like that, but it was similar to a monolithic application, if you will, that it would have one instance per virtual machine. And then when you get into the Azure Service Fabric world, as we've seen on the slide before, you can have various different microservices on each VM. You can actually even have different size VMs inside of your cluster. So if you know that red service takes up a lot of memory, we could dedicate 2 or 3 nodes just to high memory VMs and tell it to go run over there. So all that is configurable, and you can make as many modifications like that as you want to. And again, you can also set the nodes themselves to scale up and scale down, not just the individual microservices. So after talking about state, let's do a little run through as far as what data storage and data services are available to you from an application development standpoint within Azure. So one of the first things we talked about in the lift and shift scenario was just SQL Server running in a virtual machine. Obviously, that is still available up there. Some use cases that if you want to run SQL or your application in the cloud, you have to still run SQL Server inside a virtual machine. That is the fully featured product, the same way you get it on-prem. There are certain pieces of functionality that just aren't in the hosted version yet. So you may still need to run SQL Server in the VM. So all the features that are available in that today are available also when you host it in Azure on a VM. So then the SQL database, the SQL Azure one, is managed as a service. It has the elastic scale. So when you buy a SQL database in Azure, they do it based on something called DTUs, database transaction units. So you can start out at a low tier, and if you figure out that it's not enough for you, or maybe it's too much, with a click of a button, you can scale that database to whatever size you need it to be. Versus if you had SQL Server running in the VM, you can scale up the VM, but then you may need to do some different performance tweaks to the actual SQL Server itself. Nice thing with SQL Database in Azure, the hosted version, is that it also gives you recommendations on, hey, maybe you should add an index to this table because we see a lot of queries and they're going slow. So just kind of out of the box, it gives you all these performance recommendations and things that you could look at and try to tune. The middle tier on this is called Cosmos DB. It used to be called Document DB if people had seen it called that. This is a global scale document database. So it actually is globally replicated. So if you have an application that's going to be accessed from all over the world, and maybe you used to store a database in central US and one in Europe and one in Asia, and you had to have all these replicas everywhere, with Cosmos DB that isn't a problem anymore. And we're just out of the box how it is. Cosmos DB is global scale. There are 3 different methods that you can use to access Cosmos DB. Different connectors, if you will, from a programming standpoint. So there is the document database connector. So it's a queryable JSON type language that was used in the past. There's Azure Table Storage, which we'll talk about next, but it also supports being talked to in that same fashion. And then one of the real important ones is that it supports a MongoDB type connection. So if you have an application that you run on premise or even in the cloud, but you've had to kind of host your own MongoDB instance, Cosmos DB supports being talked to with the Mongo SDKs that are out there and available. So that's a big win for people who have been kind of hosting their own Mongo database and had nowhere to go from a hosted standpoint. Tables I briefly mentioned before. It's essentially a kind of a key value store. There's a partition key and a row key. You can query on other properties, but then you end up doing table scans and it isn't as efficient. But table storage is very cheap and very performant if you partition it and set up the various keys properly. And the last one in our list here is something called blob storage. Blob storage is used to store all the hard drives for your virtual machines, but it can also be used to store any types of files. So maybe you're going to let users upload files to your website. You could store all those off in blob storage. You can back up a SQL Azure database to blob storage if you wanted to. Any sort of flat file that you may want to store for long-term purposes can be stored there. And then the blob storage, depending on how much duplication you need, can be locally redundant, which is just 3 copies within the same data center. And you can go all the way up to geo-redundant, where it actually moves them to different regions or different areas of the globe, all with a click of a mouse. Blob storage is another one of those that's a fairly cost-effective product to have and to store things out on. So just a little more along the lines of the power of SQL Server and the different ways you can do it inside of Azure. Highly recommend going, at least starting with, looking at the platform as a service SQL offering. Like I mentioned before, you get the backups done for you automatically, the performance recommendations. You're not really worrying about temp DBs anymore and configuring your SQL Server to Microsoft best practice performance standards. But there are certain things, maybe you have a really large database that wouldn't really lend itself into the standard SQL Azure. Well, maybe it's to Azure SQL data warehousing, or even in that case, you may have to go to infrastructure as a service running on a VM in Azure. Check with your licensing reps, but often cases you can move your server license from on-prem up into a VM in Azure and not have to pay any additional cost on it. So within SQL on IaaS, it isn't just Microsoft SQL Server. Obviously, you can also run an Oracle server, a MySQL server, and as I mentioned, the MySQL hosted one is in preview, should be out shortly in full production mode. If you aren't aware of the gallery inside of Azure, I highly recommend you spend some time looking through it at the various pieces of software you may want to run, do a search against them, see what's in the gallery. If you wanted to run a SQL Server 2016 VM in Azure, it'd be much easier just to go to the gallery, search for it, hit build, versus going, building a clean Windows Server image, uploading your executable to install SQL Server, and put all the different configuration settings in place. When you use the image from the gallery, it has SQL Server installed already. It has all the performance tuning done for how it should run best in Azure. And that's just all in place with the click of a button, and less things for you to have to go out and do. There's also a concept of standard and premium storage disks, and premium storage disks are all SSDs. So for production workloads, that is the one that is essentially recommended as a default by Microsoft for all production SQL servers. But if you were running a dev or test SQL server up in the cloud, by all means, you can run standard disks that would be attached to those. On the large data scale side of it, just wanted to put a slide in so everybody can see at a high level what Azure is capable of. So what this diagram is showing is we have an Azure App Service that is sending data and lots of data over to a SQL database. And then every so often, there's an archiving routine that's going to run. And it takes some of that data from the main SQL database, moves it off into a SQL data warehouse. And then by using Hadoop or Azure Machine Learning, we can gain insights onto that data. Power BI, shown on the far left-hand side, is a great tool to use, very powerful. That if you haven't at least tried hooking up Power BI to any of your existing data sets, I highly recommend. There are some easy-to-use snap-ins within Power BI. So if you're using Azure, never used Power BI before, there's a connector you can install that just gives you a dashboard of your Azure usage, how much you've been spending, where your resources are. In fact, it looks fairly similar to the image that's kind of shown inside that tablet under Power BI. And again, that's just a couple clicks of a button and you have this dashboard up and running. It's just nice to be able to go in and play around with it and try to understand the power of accessing all your data in a way maybe you haven't seen before. The last topic we wanted to cover today, which is a fairly large topic, we're going to show how we can leverage some of the Azure tooling is around DevOps. DevOps is one of those things that if you ask 10 different people, they may all have 10 different definitions for what DevOps means to them. At its core, though, DevOps is trying to make the process more efficient and also increase kind of customer experience and acceptance of the product and kind of tighten up that cycle between deployment, getting feedback, updating, and doing that over and over again. So that's what DevOps is trying to achieve. So when we talk about DevOps, it's not just about the process or how we would do it. It's the people involved, the process, and the tooling that's in there. It has to be a holistic vision between all these things to really take advantage of what DevOps can offer. So what are some things that we do within the DevOps space? Automated testing. The big ones people usually talk about are continuous integration and continuous deployment. Something that is often missed as part of this DevOps practice, though, is that the feedback cycle. So getting information back from customers. Sometimes people go, well, we don't talk to a lot of our customers. You can still put tooling into your application that can provide you data about how your customers are using your application, the performance of your application, that can help you give better value to your customers. Technical debt is a huge one. There's a tool called SonarQube that if you haven't heard of before, I recommend checking that out. It'll actually run analysis against your code base, and based on industry standards or custom rules that you maybe have identified, it'll tell you how much debt you have in your code. It'll even estimate how long it should take you to fix that. So just trying to collect as much data as we can independently of actually going in there and digging in and testing all this stuff yourself so that we can do more things for the customers, make the product more efficient, make our development cycles more efficient, and just make it a better experience for everybody involved. So like I said, it's continuous delivery, which I think most people nowadays have a fairly good handle on, a CI/CD pipeline. Continuous monitoring is one that's not really used as much. When we think of monitoring, traditionally it's is my site up and running, maybe is my site performant, but the is my site up and running was always the big one. Microsoft offers something called Application Insights that is available through Azure. It's a free product to use up to a certain amount of data points per month. And that gives you great insights, if you will, into what your application is doing. Just out of the box, if you were to take a .NET website and install application insights into it, deploy it out to Azure, you would get all sorts of information simply from installing the NuGet package and putting, there's probably like 5 to 10 lines of code in to your code base. It gives you page load history, so how long are things on the page taking to render, all the way down to individual browser and location level. So maybe you have a website that doesn't run very well on an Android device. You could get a notice from Application Insights that would say, hey, for every other browser, the site takes half a second to load, but on Android, it's 4 seconds. That type of information would be hard for a developer or even a development team to glean on their own. So to have those sorts of automated notices built in is great. The other thing that you get with Application Insights out of the box is dependency monitoring. So if we have this traditional monolithic application, we can see how long all of our SQL calls are taken to go from our .NET controller down into our SQL Server. And that'll break it down based on the query you run or the stored procedure you run. And again, you're not doing anything extra to your code. You're literally installing a NuGet package, putting 4 or 5 lines of code in, and deploying it to Azure. And then you can just start to collect all of these different metrics from it. And then out of the application insights monitoring, you can do continuous learning on top of that. You can bring in other data sources. When do we do releases? When did we add in this other NuGet package? And kind of put them all together and try to learn more about how your software is working, what has worked, what hasn't, usage around how many different people are showing up. All that is available and just something that should be looked at. Again, I think the continuous delivery and continuous integration is something that most people have a very good handle on, but the ongoing monitoring of the application and learning from what you've seen in production isn't necessarily done as much. So what kind of benefits do you get from putting in a good DevOps process and workflow? We can deploy code faster. If we're doing iteratively in an agile mindset and we're keeping up to date with our customers and when they want stuff done, we're not doing these every 6-month deployments of new versions of our products. We're doing these just much faster and in a more efficient way because we can test them better. We're doing unit tests during our builds. We're doing automated UI tests when builds are done. Just trying to cover all of the regression type issues people maybe would have seen in the past. Fewer failures. Since we're doing this more, we get better at it. And the changes are also smaller. So the likelihood of something going bad reduces as a part of that. And having all these automated pieces in place as well, kind of you get away from the Friday night, late at night, somebody staying up to have to hit the deploy button for some of these releases. So it's getting the people, processes, and tooling in place, and trusting those can simplify your development lifecycle. So from a real high level, what does this cycle look like? So we have developers that are pushing to a code repository, whether this be in Visual Studio Team Services, whether this be in GitHub, Bitbucket, any of those. When something is committed, maybe at that point you have a build that runs. Some will do the true continuous integration. Other people will set up builds to run nightly. It can go either way. Once your build is done, maybe you have some automated unit tests that run against that code base. So those will run, assuming that passes, it'll deploy the application out to the cloud. One extra step that could kind of come in before the monitor and improve, once you've deployed this web application, you can also have more tests that go out and test the user interface. Maybe it makes sure that it can log into the website, that it can make an API call. All those things can be built in to part of this cycle. Once it's out there and running, you collect all the metrics you need to, whether that's through application insights or some other means, review those as developers, and the whole cycle starts all over again. So that's the how it works. This slide is kind of describing what are the various pieces that we could use to enable that workflow. So from the developer side, obviously Visual Studio has first-class support for publishing to all those various pieces. But Eclipse, from an open source standpoint, does as well. You can actually publish a Java web app from Eclipse directly up to Azure if you wanted to go that way. From a building and test standpoint, and I apologize, the slide's a little bit out of date. It's called Visual Studio Team Services now, not Visual Studio Online. That's a big component of this. There's real tight integration between VSTS and Azure, and also with Release Management Studio. So if you don't really care when or what gets deployed to dev and staging, but if something's going to get deployed to production, you want to make sure that these 3 different people have to sign off on it. So in that case, Release Management we can set up restrictions on all those things. So Visual Studio Team Services is there. You can also run Team Foundation Server on-premise as well. Jenkins is another popular option, especially in the open source community, that has direct support to publishing stuff to Azure as well. So from a deployment standpoint, obviously we can deploy as part of that pipeline, but you can also deploy via PowerShell scripts or automation scripts running within Azure. You can deploy from the Azure command line if you wanted to. And then that ongoing monitoring and learning can be done through Application Insights. If you have virtual machines that are running, you can also use System Center or Operations Manager, as it's called now in Azure. OMS is able to monitor those virtual machines and ensure that everything is running in an efficient and timely fashion. So that's what I had from a real high level. I'm not sure if they've taken questions on these things in the past. I wanted to give a really good 101 view into what you can do with developing applications inside of Azure and on top of it. The upcoming sessions we have in the Azure 123 series is on October 27th, around learning how to deploy workloads in the cloud can increase your security posture. And if there are any questions, Mallory, I don't know if we allow questions at the end of these. I didn't ask you that before.
Yes, we do.
Okay. Mm-hmm. So if there are any questions, feel free to ask.
Justin, I think you have to unmute people.
Oh, I thought you were okay. I can unmute.
All right, I unmuted everyone if anyone has any questions.
Yep. Does anybody have any questions? Okay. Well, I appreciate everybody's time. Feel free to reach out to us if you have any questions that come up after the fact. And everybody have a good Friday and enjoy your weekend.
Yep. And the slides, the presentation and the slides will be sent out on Monday.
Thank you, everybody.